Hey everybody, I hope that you're doing well. Welcome to lesson 2. So last time we looked at the number line and worked on comparing numbers and absolute values and opposites and reciprocals and adding, subtracting, multiplying, and dividing negative and positive numbers. Well, the idea of being able to divide two numbers leads us into fractions. Because if you think about it, if I take 4 and divide it by 5, that is just 4/5. So this starts the idea of fractions. So we need to talk a little bit about fractions. I know that's like an F word to everybody. That's usually math people or non-math people's least favorite thing is when we start talking about fractions. But I'll make this as painless as possible. The first thing is always fun to ask, how comfortable are you with fractions? And most people are not very. But what you find is people that do a lot of math would rather do things with fractions. They actually prefer fractions. You kind of get a coziness. They're actually easier to work with once you have it kind of nailed down. So let's kind of start with an idea. Let's start with we need to talk about what equivalent fractions are. Oh, computer's lagging a bit. Equivalent fractions. What does it mean when fractions are equivalent? I'll give you kind of a lame definition. I don't want to give you the massive textbook ones. That just means they have equal value. And so I'll give you an example. 1/2 is equivalent to 3/6. They have equal value. And you could think of this by just thinking of, well, a pizza or something. It's actually quite simple. Let's say I'm able to cut this into, I probably can't, but 6 pieces. Okay, there's 6 pieces. And you ate 3 of the 6. You have eaten 3/6 of the pizza. So 3/6 of the pizza. That is half of the pizza, right? You've eaten half of it. These things are equivalent. They both mean the same thing. Another easy way to check this is to take your calculator and instead of writing them as fractions, you could do 1 divided by 2. Fractions and divisions are the same thing. 1/2 is 1 divided by 2. Your calculator will tell you 0.5. It'll give you the decimal. And if you do 3 divided by 6, it'll also tell you 0.5. So these two are in fact equal or equivalent fractions. Okay? So that's a very simple idea. I just wanted to kind of lay that down before we start doing a little bit more work. Well, what are we kind of going to start with? We're going to start with trying to reduce fractions. Okay. Reduce. I guess I should just go with reducing. That's probably better English. Reducing fractions. Well, the big question is, well, what does it mean to reduce a fraction? Well, that means that we are trying to look for equivalent fractions and keep reducing down through equivalent fractions such that so the top and the bottom, the numerator and the denominator, the top and bottom have no common factor. Okay. What that means is there's no number that can divide evenly into the top and bottom of your fraction. So we're going to keep looking at equivalent fractions, trying to get basically the smallest version of your equivalent fraction. So there's no common factors in the top and the bottom. Let me show you what I mean. If I take 18/24, this is a nice fraction, nothing wrong with it, but it's not reduced because the top and bottom have a common factor. Is there a number that divides evenly into 18 and 24? The answer is yeah, there's actually several numbers, but I'll show you one. 2 divides evenly into 18 and 24. And if I were to do that, 18 divided by 2 is 9, 24 divided by 2 is 12. So we have reduced this fraction. Well, the question is, are we done reducing? Is it reduced all the way down? And the answer is no, because ask yourself, is there a number that divides evenly into the top and the bottom? And the answer is, why, yes, there is. 3 will divide evenly into the top and the bottom. And if I divide by 3, 9 divided by 3 is 3, and 12 divided by 3 is 4. Okay, so these 18 over 24, 9 over 12, and 3 over 4 are all equivalent fractions. If you multiply or divide the top and the bottom by the same thing, you stay equivalent. You don't change the value. Now, am I reduced? Am I done reducing? Well, is there a number that divides evenly into 3 and 4? And the answer is no, so we are reduced. Okay, so we can do this a lot quicker because there's actually a bigger number, a larger number. Well, first let me mention you could have noticed that both are divisible by 3 first, but then you would have needed to divide by 2 again. But there's actually a larger number that divides evenly into both of those, and that happens to be 6. 18 divided by 6 is 3, and 24 divided by 6 is 4. So you could have jumped to the answer a lot more quickly. So if you can find the largest number that will divide into both top and bottom, you can move to reducing a lot faster. Okay, so let's look at a few more examples of this. So for instance, could we do 5 over 20? The answer is yeah, that's not bad. What number divides evenly into both 5 and 20? A lot of people forget that you can divide a number by itself. 5 divides evenly into 5 and 20. 5 divided by 5 is 1. 20 divided by 5 is 4. And so we can easily reduce that one down. Let's do another one. How about 12 over 3? It's very similar to the one I just did. What number divides evenly into both? Well, that would be 3. 12 divided by 3 is 4. 3 divided by 3 is 1. Well, wait a second. Last lesson, I showed you when we were working on reciprocals that I don't want to leave a number with the 1 on the bottom because 4 divided by 1 is just 4. So if there is a 1 on the bottom, I can turn it into a whole number. Now notice that's very different, very, very different than if there's a 1 on top. This is not 4. This is 4. Let's do some more examples. How about 10 over 15? Is there a number that divides evenly into the top and the bottom? There is, so it's not reduced yet. Let's reduce it. 5 should divide evenly into both of these. See, 10 divided by 5 is 2, and 15 divided by 5 is 3. So yeah, we can reduce that one down. And let's hit 1 or 2 more, maybe one more. 75 over 12. Is there a number that divides evenly into both of these? And some of these you'll have to think about a little bit. The answer is yeah, there is a number. It happens to be 3. 75 divided by 3 is 25. 12 divided by 3 is 4. And that is reduced as far as you can go. Okay, so reducing is not bad. So I will say you need to make a special note to yourself that in this course, we require all answers to be written as a reduced fraction. So I'm pretty nice. I would like to give you full credit if the answer is 12 over 3 and you tell me 12 over 3. But this is a coordinated course. All the Math 105s are taught with the same standards and curriculums and tests. And so it's been agreed upon by the group that if you tell me it's 12 over 3, I have to take off some credit because this can reduce. It's not all the way done yet until you tell me it's 4. If you tell me 75 over 12, you will get most credit, but you will lose credit unless you reduce. So reducing is important for getting full credit on everything. Okay. So now that we can reduce fractions, let's talk about operations with fractions. Okay? Or let's actually do some operations with fractions. We're going to start with the easy ones, multiplication and division. We'll start with multiplication. Multiplying fractions is super easy. If you don't know the rule for multiplying, now multiplying, adding is very different, but multiplying fractions, all you do is you multiply the numerators with the numerators, the tops with the tops. So the top will be 2 times 3. I know that's 6. I'm just taking the time to write it out. And the bottoms by the bottoms, 5 times 4. So multiplying fractions is really easy. 2 times 3 is 6. 5 times 4 is 20. Now, I can't leave my answer like that. I do need to check to see if it reduces. And they are both even, so I know they both divide by 2. You may want to write in your notes that this is where you're reducing. You've finished the multiplication, but now I got to think about reducing. 6 divided by 2 is 3. 20 divided by 2 is 10. That's reduced. So there's our final answer. Okay. Let me hit some more examples. How about negative 1/2 times 5 over 2? Well, multiplying, like I said, is really simple. Tops times tops, so 1 times 5 is 5. And on the bottom I have 2 times 2, which is 4. Now notice I have a negative sign. What's a negative times a positive? An ugly mama and a pretty daddy? That makes an ugly baby. Now 5 over 4 doesn't reduce, so we're finished. That was pretty simple. Let's do another example. How about, what if I do a fraction times a whole number? That tends to mess people up, but just last lesson we talked about finding reciprocals. And in that, the first tip I gave you for finding a reciprocal of a whole number was I can turn each whole number into a fraction by putting a 1 underneath it. Well, this makes multiplying extremely easy, because now I have a top and a bottom. So 3 times 8 is 24, and 2 times 1 is 2. Now does that reduce? Yeah, it does. They're both divisible by 2, right? 24 divided by 2 is 12. 2 divided by 2 is 1. I can't leave it with a 1 on the bottom. 12 divided by 1 is 12. Of course, you probably could just, at some point, you can get to where you skip showing some of these steps. I'm just being a little bit annoying and showing everything since I'm teaching. Okay. Let's look at maybe one more multiplication. Let's go 3 over 8 times 8 over 5. Okay. And I want to show you something. Noticed here I was annoying and wrote it out before I did the multiplication. You can always do that if you want to, because we just multiply on the tops, 3 times 8, and multiply on the bottoms, 8 times 5. But this can be helpful. I'll show you why. Let me work it the way we've been working it. 3 times 8 is 24, and 8 times 5 is 40. And then you got to work hard to reduce this. You're thinking, oh, what goes into both? I'm not sure. I do know 4 goes into both, so let's try that. That'll give me 6 and 10. Well, that wasn't everything, because now this is both divisible by 2. So 6 divided by 2 is what? 3, and 10 divided by 2 is 5. So finally I have it reduced. But that's kind of a large, it's not too big, but kind of a large number. It would be cool if I could reduce before I get to these numbers if possible. Well, if I write it this way, notice I have an 8 on top and an 8 on the bottom. If you have same numbers on top and bottom of the fraction, once you smush them into a single fraction, you can reduce certain pieces of these. So for instance, 8 and 8, they're both divisible by 8, and they will divide each other out or away. So I could have just immediately seen that this is going to be 3 over 5 without really any work. Over here, I could have done the same thing with 8 and 2. They reduce. Let me write it down. If I were to write it as a single fraction, then I have something on top that can reduce with something on the bottom. 8 and 2 are both divisible by 2. So leaving the 3 and the 1 alone, 8 divided by 2 is 4. 2 divided by 2 is 1. Okay, so I did these chunks and left the 3 and the 1. Now 3 divided by 4 is just 12 over 1. So you could have gotten there a lot faster. Just, you don't have to do that, just another way. You can reduce before you start multiplying. Alright, now let's look at some divisions. So this is where I'm going to use the idea of what a reciprocal is. So remember when I taught subtraction last lesson, I told you that here's the rules for adding. We don't need rules for subtracting because subtracting is just adding the opposite. Keep, change, or keep, change, switch. It's very similar for division. Okay? Division is multiplying by the reciprocal. And the good thing for us, we know what a reciprocal is. That's just the flipped fraction. So let me give you an example. If I take 2/5 and I divide by, let's go with 4 over 10. No one in their right mind is going to want to do this as a division. But I know that a division is the same thing as a multiplication of the reciprocal. What is the reciprocal of 4 over 10? It's 10 over 4. So I can turn this division into a multiplication and flip the second fraction. Now I already know how to do this. That's what we did on the last page. It's just a multiplication. I have 2 times 10 and 5 times 4. So that's what? 20 over 20. And I'll go ahead and start reducing a bit faster. They're both divisible by 20. Will give you 1 over 1, which is just 1. So I can turn every division into a multiplication by a reciprocal. And I will go ahead and tell you this is huge for a chapter in 111 where you deal with big fractions. You have to understand some of these fractional concepts for dealing with the big fractions in Math 111, which is your goal, right? You're taking 105 to get to 111. Let's do another example. What if I did 30 over 7 divided by 15? Well, this is that same problem we had earlier. This is a whole number, this is a fraction. Let's turn them both into fractions because I can add a 1 on the bottom. Now, every division can be turned into multiplying by the reciprocal. So I changed it from dividing by 15 to multiplying by 1 over 15. And then this gives us a lot simpler of a problem to handle. It's just multiplying. Now this is going to be a really large number. Maybe before I multiply, I'd like to reduce. Notice that 30 and 15 are both divisible by 15. Okay, so let me kind of get ready. Times 1, 7 times. Let's see what goes in these two spots. 30 divided by 15 is 2. 15 divided by 15 is 1. So I get 2 times 1, that's 2. And 7 times 1, that's 7. So that was a lot easier to reduce before I multiplied. Because otherwise you'd end up with 30 over, 75? And have to reduce that down. Alright. Okay, so multiplying and dividing fractions are not really hard. Actually, it's only multiplying because there's no need to do a division. But let's talk about adding and subtracting now. This is actually where the most work is in fractions. That's because you have this one huge need. I cannot add or subtract until we have something special. We need a common denominator. That's the bottom of the fraction. Okay, we need the same bottoms. So for instance, if I already have the same bottoms, let's see, like 3 over 7 plus 2 over 7. it's a piece of cake to add or subtract. It doesn't matter. Let's do it as a subtraction, just for fun. To add or subtract fractions. Because what they're going to do is you keep the same denominator, and you do the operation adding or subtracting on the top. So 3 over 7 minus 2 over 7 is just 3 minus 2 over 7. Notice that same denominator stays the same. The tops are where the operation happens when we're adding and subtracting. Now notice this is very different from multiplying and dividing. Please keep them separate. And of course we can do 3 minus 2. That's just 1 over 7. Now the problem comes in when we aren't gifted this beautifully nice denominator. So something like this, 3 over 5 plus 1/2. Well, how are we going to handle this? It's not too bad. What we're going to do is we're going to use our one tool, the tool we have to change denominators. Whoops, I can't spell. The tool is multiplying the top and bottom. Now it has to be by the same number. So look here, 3 over 5 and 1 over 2. They are not the same denominator. So I'm going to multiply 5 by a number and 3 by the same number. And I will multiply 2 by a different number to try to get these denominators to be the same. Usually there's a lazy approach you can take. Okay, 5 times 2 is 10. I can get them both to 10. So how would I get this one to 10? I need to multiply the bottom by 2. Now whatever I do on the bottom, I need to do on the top. So this fraction becomes 6 over 10. Now why did I choose 2? Because I'm trying to get the bottom to be 10. How did I choose 10? Well, what are the two denominators that I have? 5 and 2. 5 times 2 is 10. Bring down your operation, your plus sign. And now let's multiply 2 to get 10. What would I need to multiply by? I need to multiply by 5. Whatever I do on top, I need to do on the bottom. So I get 5 over 10. So if you look, these are equivalent fractions here and here. So now, since they have the same denominator, I can smush them into a single fraction where I keep the denominator the same and do the operation on the numerator, 6 plus 5. 6 plus 5 is 11. 11 over 10 is my final answer. That does not reduce, so I'm finished. So maybe 1 or 2 more examples of adding and subtracting, because that is the most work as far as fractions go. 2 over 7 minus 1 over 2. Well, let's get them to have the same denominator. 7 and 2. 7 times 2 is 14. So let's try to get this to 14. What do I need to multiply it by? 2. That give me 4 over 14 minus, let's see, I want to get this one to 17, so I'm going to multiply by, sorry, not 17, 14. Multiply the top and bottom by 7. 1 times 7 is 7. 2 times 7 is 14. So now you notice they have the same denominator, a common denominator of 14, and I'm doing the operation of 4 minus 7. What is 4 minus 7? That's just negative 3. We already know how to do that. This doesn't reduce any, so I'm finished. Alright. Now, I think you get the point. I do want you to practice your worksheet. I do have one last big point to make. We allow calculators in the class. This all can be done on calculators. Yes, it can. But you got to be extremely careful entering this stuff in a calculator. Okay. Learn how to do it by hand. Do your worksheet by hand. And then you can play with your calculator to see if you can figure out what you need. I'll go ahead and tell you, a lot of these can type in as in your calculator as long as you use parentheses to make each fraction. So let's say I have, what was the example we just did? 2/7 minus 1/2. If I'm going to type this in my calculator, 2 over 7, that's the same thing as 2 divided by 7, but I need to put parentheses around it, minus, put my next fraction, 1 divided by 2, and your calculator will be able to spit it out. Now, it'll give you a decimal, but there is a button somewhere on most calculators. If you get the one the course suggests, you can turn it back into a fraction. Let me see. The one we suggest is the TI-30XS calculator, and I can just pull up a, where's the image? Pull up an image of this. And let's see if I can make it ginormous. Oh, I didn't want it. I wanted the image, not the, I'm so stupid. Images. There. Let's make it big. Okay, that'll do. And what you click on is this button right here that has the arrow to the left and the right directly above enter. If you have a decimal in and you press that, that'll convert you to a fraction. So this thing can be used to reduce fractions. It can be used to add, subtract, multiply, divide. You just get your answer as a decimal, then press this button right here, and it'll give you the reduced fraction. Okay, and that's quite expensive for this calculator. You can find it on Amazon usually for pretty cheap. Usually the 30XS is usually $14. I don't know why that one's so expensive for. But anyways, so that's all I got for you. So go try that worksheet. Try it. I would try it by hand and then check all your work with the calculator and see what you think. Okay, just for the test, be able to get the correct answer, calculator or by hand or whatever you're most comfortable with. All right. Well, have an awesome day, and I'll see you guys later.